In this lecture, I'm going to discuss about one scenario, and in that scenario, we'll discuss when to use JMS and when to use VM queues. And also, we'll briefly discuss about clustering, concepts around clustering, and how using a combination of VM queues or JMS queues along with clustering will help us to improve performance. So let us take a simple scenario. I want to read from a file. Let's assume that there's a CSV file with thousands of records. A CSV file with say 10,000 records. Now what I want to do is, I want to poll for file using on new or update file. Get it? And then I want to insert into database, right? So one thing I could do is I could use a file component on new or update file, do transformation of the CSV records, and then what I could do is I'll be getting a list of records after transformation, right? And then what I could do is I can use for each scope, right? For each scope, and then I will write a insert. I'll use insert database component to do the insert. Is this a good solution? It works in ideal situations, but what if I get 10,000 records and my for each is iterating through each record and inserting. After it inserts 500 records, what if the connection is gone? Is it? So we lose our records. Is it? So how to make this more reliable? Okay. So what we could do is we could write a flow like this. Again, a flow which contains file on your update file component, and then a transformer, and then in for each, inside for each, I could use a JMS component to send a messages to a broker managed queue. So what will happen? All the 10,000 records will go to JMS queue. Okay. Then what I could do is I could have one more flow where I will be having a JMS listener which will poll for new records from here and then do the processing. So in this case, what happens is once the file is read, it is returned to JMS queue. And from there we read and then we process, right? So if we are doing in this way, if I write an application in this way, one more advantage in terms of performance also is there. Firstly, it is reliable because all the records will first go into this queue, and then in another flow we are fetching the records and processing it, so we will not miss processing of any records, and I'll achieve concurrency. Here in this case, once I receive, multiple threads will execute this flow, right? Whereas in this case of for each, whereas in earlier case, single thread will iterate and insert. Instead of single thread, if I follow this approach, multiple threads will concurrently receive multiple messages and then process them asynchronously. Performance also is increased a bit, right? Now, one problem here I see is, what if there's a problem with JMS connection itself? Is it? My Mule application is running, but JMS connection has some problem. The JMS broker went down or something like that, right? So again, this problem may occur. And also I see that the Mule message will go out of my application to broker, and from there I am receiving and then processing. A lot of network also is involved, right? Will it not be good if I have some queues in memory? Yes. So for that there is one more thing called as VM connector, where a VM connector will allow us to send messages to in-memory VM queue, a queue which is in our memory. So instead of using broker managed queues, what I could do is I could design a flow like this with again a file reader component, transform it. Now inside for each, what I would do is I will use a VM connector to push or publish the messages to a in-memory queue within the same Mule runtime. Now in another flow, what I would do is I would use this VM listener component to listen for messages inside this virtual memory queue and then process it. So in this one, what I am achieving is one thing. Immediately after I receive the records from a file, after transforming, I'll push all the messages, 10,000 messages to this queue. Since this whole thing is in memory, there is no network issue. So there is no chance of network going down, right? Because everything is in memory. And also this VM listener is receiving the messages in memory. So this is better than using JMS queues, right? But this VM endpoint and VM queues are inside the Mule runtime. They do not provide all the features which a message broker provides. There are a lot of other features which a message broker provides. So if you just want a queue, then you can use a VM queue, a queue inside the same VM, right? So again, let me talk about this VM queues. This VM queues can be configured to persist all the messages either in memory or in or it can be persisted. The VM queues can be configured to be persistent. So if I make this VM queues as persistent, whatever messages are going into this VM, they will be persisted into a temporary folder. So in case while processing the records, if the whole Mule runtime crashes also, the messages are not lost. Once my Mule application is up, it will again, the VM queue will again read all these messages from the temporary file, and then the processing happens. So there is no message loss. So we can achieve reliability. The messages are not lost at any case if I am using VM queues, right? That is one thing. Now let us see how these VM queues work in case if I have a cluster of Mule runtimes. So let's assume that I'm going to create a cluster of Mule runtimes. I'll show you practically later. So these are two Mule runtimes, right? I'm creating a cluster out of them. So what is a cluster? Cluster is nothing but a set of nodes which act as if it is a single node. Is it? Yes. So let's assume that my application is deployed into the cluster. So it will get deployed to all the nodes of the cluster. Yes. Right. Now, if my application is using VM queues, what can happen is the VM queues will be stored inside something called as Hazelcast distributed shared memory. So Hazelcast is a framework which allows us to create a distributed virtual shared memory. Actually, let's assume that this Mule runtime is on a different machine and this is on a different machine. They are not physically present at same location. They are different. How can we get a shared memory? Since there are two different machines, we don't. Let's take an example. I have a cluster of 3 Mule runtimes and my application gets deployed to 3, right? How can we have a shared memory for these Mule runtimes which are on different machines? It is not possible. But Hazelcast allows us to create virtual distributed shared memory. So I don't want to go into the concepts of how this virtual distributed shared memory happens. It's a technique where the data will be replicated on some nodes. So we can just tell what is the quorum size. If I configure something called as a quorum, right? If the quorum is 2, what this Hazelcast will do is it will actually store the data in at least 2 nodes. So even if one of the node entirely crashes, the data is not lost. So I don't want to go into the details of Hazelcast, but I want you to understand conceptually here. Hazelcast is a framework which allows us to configure virtual distributed shared memory. Whenever you configure a cluster of Mule runtimes, automatically this Hazelcast distributed shared memory will be created. Now, whatever virtual queues we create and we make them as persistent, all the persistent virtual VM queues will be created in Hazelcast shared memory. So both the applications will be pointing to the same queue. Now, if you see my application, this queue is not inside the runtime. Okay, this queue is inside shared memory. So assume that file is read from one of the node, right? Node 1 has a file reader. Node 1 is primary in the cluster. This is node 1, Mule runtime 1, node 2, node 3 in a cluster, right? So assume that this is the primary node. We can configure the file polling has to happen one of the primary node. So on this, the first flow will get executed, and what the first flow is doing, it is pushing all the messages to VM queue. So on this node, the first flow gets executed. All the messages are now pushed to VM queue. All the 10,000 messages. Now what happens? Second flow is running on all the 3 machines, right? This VM listener, which is running on 3 machines, will try to poll. So all the messages will be actually received by second flow in all the machines, and they will get processed on 3 machines. So don't you get the messages are processed asynchronously, concurrently, or parallelly by 3 machines? Yes. So if you are using VM queues, this is one scenario. If you want load balancing to happen in a distributed, whenever you have a cluster, we can use VM queues, right? But whatever I discussed about Hazelcast is when you are using a Mule runtime on premise. That means customer hosted runtimes. Whenever you are using a customer hosted runtimes, this is the scenario. Let us now try to understand how this persistent VM queues work in Cloudhub. Very important in interviews or in certification exam. There are a lot of questions related to persistent VM queues in case of Cloudhub. So let us try to understand this clearly. Suppose if you are deploying an application on Cloudhub, what happens? Your application will be started in a separate virtual machine. This is a VM on AWS, right? So suppose if you are deploying your application on 3 workers, so 3 virtual machines will be created and your applications will be running within this virtual machines. So in your application, if you are having a persistent VM queue, what will happen? So actually, there will be a network storage within AWS that will be attached to all the three VMs. Same network storage will be attached to all the workers. So suppose on this node, if you are writing to a VM queue, what will happen? As this is configured as a persistent VM queue, whatever you write inside this VM queue will be written to the network shared drive, network storage. So the same thing is mounted onto other VMs. So if in this VM, if you're writing to this VM queue, this VM queue is also pointing to the shared network storage. So all will be able to see it. So that is how it works in Cloudhub, Cloudhub 1.0. Okay. So let me actually point you to the documentation. A very important documentation is there. I will read this documentation for you for various scenarios. Let us discuss. Actually, in MCIA certification exam, there are a lot of questions attached to this. So very important. Please listen to this. So actually what I did is I went to Google and Googled for persistent VM queues in Cloudhub. So I took the first link, persistent queues explained. This is actually from the help.mulesoft.com. Here they explain. So first of all, let me tell you before I go through it, if you have persistent VM queues in your application while deploying to Cloudhub, see, this is runtime manager. I'm deploying to Cloudhub. There is an option called as persistent VM queues, persistent queues. You have to enable this. Otherwise, even though within your application, if the queues are configured as persistent queues, but during deployment, if you don't check this, your VM queues will work exactly like in-memory queue only. So first thing to be noticed. Okay. Now let us see the other options. See, Mulesoft deployed applications utilize Cloudhub persistent queues. So this is the article which explains. What is this Cloudhub persistent queues? Cloudhub persistent queues is a cloud service that allows messages that are published to VM queues to be stored externally to the application. So where they will be actually stored externally to the application in a network shared file system. So I'll actually point you to here. Here they have given persistent queues, a network attached storage, right? Okay, let me go through it sequentially. So what is Cloudhub persistent queues? Cloudhub persistent queues is a cloud service that allows messages that are published to VM queues to be stored externally to the application. You just have to enable persistent queues. Actually, in trial version, we don't have this option. In licensed version, you can enable it. So if you enable it, then this allows the data published to persistent queues to be stored externally. This feature is directly tied to Cloudhub Fabric feature and is part of Cloudhub's high availability infrastructure. When Cloudhub persistent queues is enabled, it allows the developer to design VM queues in such a way that payloads can be shared across different workers for the purpose of load distribution. So all the workers will be sharing this persistent queue. The data, whatever is in persistent queue, will be visible to all the workers. So load distribution will be enabled by default. In the case of failure of one worker in multi-worker deployment, messages on the queue are able to be consumed by other workers, ensuring continuity. So even if one of the machine VM crashes, no problem. The data is still available on the network, right? Network disk, network storage. So it is okay. How to enable Cloudhub persistent queues? As I told you, in Cloudhub, there is an option enable persistent queues. This is what they are saying. So this feature is only available for customers who have platinum and above subscriptions. Okay. Now, what are the use cases? Cloudhub persistent queues is a specific feature for a specific task. Its design is solely to enable capability to share payloads across multi-worker deployments. So it's only the sole purpose is to have shared data across multiple workers. Okay. It should only be used for this purpose. Enabled for this use case, Cloudhub persistent queues will enable high availability, resiliency, and performance due to load distribution. Okay. So what are the use cases that are not suited? Okay, the use case is reliability pattern. What? The Cloudhub persistent queues should not be confused with traditional Mule persistent VM queues. So Cloudhub persistent queues are different, and on standalone VM, the Mule persistent VM queues are different. While persistent VM queues are intended to be part of reliability pattern solution, that was never the intention of Cloudhub persistent queues. So don't use this Cloudhub persistent queues for achieving the reliability pattern. The strong recommendation is that Cloudhub persistent queues should not be considered as a feature to use when designing reliability pattern in Cloudhub. Okay, what is this reliability pattern? There will be a separate video which I'll be discussing about reliability pattern and how to apply it. So this documentation says don't use Cloudhub persistent queues for implementing reliability pattern. With that said, Cloudhub persistent queues should never be enabled for single worker application. What is the main purpose of Cloudhub persistent queues? Load distribution across multiple workers. So if you are having a single worker, don't enable them. It was never the feature for that. For true reliability pattern, the queues used should be an enterprise grade message broker, like any point MQ or active MQ, etc. So if you want to implement pure reliability pattern, don't go with persistent VM queues. Don't go with it. So you can go with broker queues. Now, what are the limitations? Applications with Cloudhub persistent queues will process messages up to or more than 10x slower than not using Cloudhub persistent queues. So the performance will be 10 times lower if you are using Cloudhub persistent queues. This is given in the documentation of Mulesoft. So carefully enable Cloudhub persistent queues. The performance is further significantly decreased if you are using encryption option. The reason is because Cloudhub persistent queues use a network attached storage. That's what I was telling, which has both network latency and a physical limitation in terms of read-write speed. When persistent queues checkbox is unticked, the VM queues will be stored in memory or local file system based on the VM configuration. So if you uncheck this persistent queues option in Cloudhub, if you uncheck this, as I told you, it will behave just like in-memory queue, or they will be stored in local file system, right? Fine. Again, here you need to know each and every point for certification exam. One time only message delivery cannot be guaranteed with Cloudhub persistent queues. So duplicate messages can be sent. If your solution requires strict one-time only delivery, don't use Cloudhub persistent queues. And most importantly, this is the question for certification exam. Cloudhub persistent queues will be retained for 4 days. And this retention is not customizable. Because of this, Cloudhub persistent queues should not be used for any long-term storage. And most importantly, when using persistent queues, when you are selecting this persistent queues checkbox, and if you are having batch jobs within your application, let us see. Mule batch jobs internally use queues. As we know, there will be a queue, right, in batch job also. Yes. When Cloudhub persistent queues is enabled for an application with batch processors, severe performance degradation will occur. So never enable persistent queues if your application is having batch job. Okay. Documentation says batch job also has its own limitations. If using persistent queues, severe performance degradation will occur. The significant one being that message reliability is not guaranteed. Again, in Cloudhub persistent queues, as I told you, it is not for achieving reliability. So it is possible that message loss can occur in case of application restart. This limitation means there is no benefit of having Cloudhub persistent queues enabled for batch job. So Cloudhub persistent queues should not be enabled if your application is having batch processors. So just make a note of this URL and go through it. It has a lot of pointers when to use Cloudhub persistent queues, how this Cloudhub persistent queues work, right? Everything is there. And if you want more documentation, here they have given you the link to the documentation which explains clearly about persistent queues. I highly recommend you to go through this documentation once and remember all the points, because in certification exam, there is a high chance that the questions from this pages will be there. That's all. Thank you.